What's going on, everybody? Johnny Bannon here at Trepa Technologies. In today's video, we're going to be going over domain 3.1 of our Network Plus course. So we're going to go ahead and get started here. This is going to be what I think another kind of boring section. It's just going over documentation, change management. But it's these kind of skills that get left behind a lot in very technical jobs like being a network engineer that maybe we're not as interested in, but it's a very important part of the job because as an engineer, documenting, having good processes, having good backups, and a golden configuration, what we're going to learn about, is just as much as part as being a good principal and senior network engineer. And those skills start at the junior network admin level here at the Network Plus exam. That's kind of what it's training you to be. So let me get my face out of the way, and let's go ahead and jump right into it. So as you can see here, here's our objectives. So we're going over documentation to include different diagrams, asset inventory, and then touch on things like IP address management. Then in our next video, we'll touch on these objectives over here on the right. So when I was looking at these Network Plus exam objectives, doing network engineering for the better half of 9 to 10 years, anytime I started building a diagram, we just called it the network diagram. We used tools like Visio, Draw.io, and when we'd have to, let's say, map out an outsite or spoke that we're going to build, and then we come back and do revisions after the site build, I never said, oh, let me get a physical diagram, let me get a logical diagram. I just called it the network diagram. So when you're working at that NOC and you do the Network Plus exam, you may not want to, the network engineers there may say, hey, that's just our diagram. And that diagram may have elements of physical, logical, and the network combined in that diagram, okay? Now, for the Network Plus exam, that's what we're here to pass. We're going to go over the exact definitions here, okay? So, a physical diagram. These diagrams represent the actual physical connections and layout of network devices such as routers, switches, and servers. They show how devices are connected through cables and their physical placement in the facility. So, you can think of this as saying, oh, we have access switch 4 on floor 1. And that's connected to the distro switch via the gig 1/1 port, okay? And that could be a physical diagram. So correlating physically where equipment might be. And that may just be the geographical location as well, right? In that same vein, if we have our headquarters in Washington, D.C., but we have a spoke in Fayetteville, North Carolina, well, maybe that physical diagram says, okay, yeah, this router and the downstream switches is in Fayetteville and at this address in this building, and our switches are located in this comms closet on this IDF or rack. That could be part of your physical diagram. Then we have a logical diagram. So logical diagrams focus on the flow of data within the network and how devices interact. So this may be a diagram that has a router located in, again, DC, that router located in Fayetteville. But instead of putting locations, the ISP connection, you put the GRE tunnel that connects them or the IPsec tunnel that connects them, right? So you're logically showing how data flows from site to site within your enterprise or within your network. Now, talking about a logical diagram in the LAN, this may show the different broadcast domains, subnets, VLANs, the SVIs on that switch, and how the data flows, right? So that's kind of what I have up on the screen here. I would kind of consider this more logical diagram, right? Because it's not showing where those web servers, where those ESXi server for the vMotion is. It's not showing any of that. It's just saying, hey, here is this compute storage, here's this resource, here's a subnet it's attached to in the VLAN, and its gateway is all going through that core switch there, and that core switch leads out to a firewall that leads out to the internet, but we don't know physically where all that stuff is. This is good for troubleshooting remotely, right? Now, if we had a guy on premise that had to find where this stuff is and find, well, ESXi server, okay, well, what port, what interface am I looking for? This wouldn't be a good diagram for that, right? So you can kind of see how this is good for troubleshooting the network flow, but if we're doing on the ground, on-premise troubleshooting, and we got to know, hey, this fast Ethernet 01, is that the trunk to that core switch? Or what is that, right? Okay, moving on. So a rack diagram. So a rack diagram is going to look at your data center racks. This is pretty important if you're doing data centers. You may have a rack diagram along with your network and logical diagrams. This could be good for your comms closets, right? You could say, hey, we have 6 racks in our 6-story office building. Rack 1 is on floor 1, and here's the patch panel for it, and here's all the resources in there. We have switches. Maybe on that rack 1 on floor 1, that's where our storage is, right? Maybe we have some sort of like SAN or NAS in there. So a rack diagram is a visual representation of how equipment is physically arranged within racks, network racks. Then we have cable maps and diagrams. So cable maps are used to document the physical connections between network devices. This includes documenting where cables run through a building and which ports on the devices are connected. Now, personally, from my years in network engineering, I never had something specifically built for cable maps unless I was working with our E&I teams, what we called them, our like infrastructure guys that did the fiber for us. And they would sometimes come with me to the comms closet. I had to let them in, say, here's our fiber distribution panel. They would shine their lights. They'd have their devices that made sure the fiber was working properly. And they had, diagrams, and they would show me like, okay, this is supposed to be going to this circuit over here. This is why you don't have data coming in this way. So those cable maps and diagrams are very important when we have a lot of cabling, a lot of IDFs, MDFs, and like maybe some miles of fiber, right? So cable maps are used to document the physical connections between network devices. This includes documenting where cables run through a building and which ports on the devices are connected. Okay, and then the network diagram. Now this is what, you go work in a NOC, you become a net engineer, a net admin. This is what I'm used to seeing and what I'm used to building, right? Where we have our network infrastructure here. We're showing the IP addressing. We're showing the interfaces along with it, and maybe some other things like, oh, this is being load balanced. This is the primary connection. This is the secondary connection. This is where our DMZ is, right? And on here, maybe you would put some physical location. So let's say we're going to do a little like hands-on thing here. Let's say that you're a junior network admin and your first task is, hey, go to Outsite 1 or go to this spoke site in Chandler, Arizona. And we say go to it, we mean SSH to the router, right? And using this diagram here of where we think things are located at, start building a network diagram. So you may have already like, oh, okay, based off this switch's host name, this says this is access switch 1 on floor 1 of this building. Through the show CDP neighbors commands or wherever, let's map it out. And now let's go on Visio and actually build the network diagram, okay? Or maybe you're building it via SolarWinds. So you're using SNMP, integrating that into your map building. Maybe you use things like NetBrain or Forward Networks or these other technologies that help you map. Now, doing it the old-fashioned way, here's how you would start, right? So let's say if I'm building one, this is on a whiteboard, right? Which sometimes is how we start building the actual network diagrams in Visio or draw.io on a whiteboard session, right? And we'd say, hey, the ISP out there, actually Chandler, Arizona, is Cox. That's our ISP connection. What kind of ISP connection is this? Let's just say, for example, this is MPLS, okay? And then how I would start building this network diagram is I would put that host name. What router is this? So maybe this is our host name scheme. We say, hey, this is the Chandler R1 router, okay? And we say, what kind of interface is that? Let's just say it's actually a gig port, right? Not a serial, anything weird like that, okay? And then what are we connected to? Let's say we're connected to 2 distro switches. So now we start drawing this out. So we say, okay, what's the name of these distro switches? Let's say this is distro switch 2. And obviously our host names for this may be a little different. And then what else do we want to put here? Okay, on the router, that was gig 0/1. This was gig 0/2. And on each switch, that's gig 0/0, gig 0/0. And then between these switches, let's say we have an ether channel, right? So we say, oh, this is port channel 10. And then, obviously, we zoom in here. Maybe we want to put, okay, this is, let me make my lines a little smaller. This is gig 01. This is gig 01. This is gig 02. And this is gig 02. Okay? So we have 2 distro switches there. All right, then what are these distro switches connected to? And maybe before we move on, we do put some physical things in there. Maybe we say, in this little like dotted line here, this is in comms closet floor 1, right? So we know all that's in floor 1. And maybe we say, hey, this is also our main distribution frame. So now we're just looking at the network. Well, now let's say, oh, well, actually, there's actually some compute resources here at our MDF. So now I'm going to redraw some of this network. You just kind of see we're building it here. So maybe we have a web server farm that's connected to distro switch 2. And that's also a port channel. So we draw this out, right? And we say, okay, what web servers are in there? So maybe this is EXXI host 1. And then we just keep going from there, right? And then we draw our access switches. And then maybe these access switches, if we want to get very particular, we can put what computers, printers, or VoIP machines, or voice machines, or VoIP phones are on there, okay? So you kind of see how we start building this out. And we wouldn't, maybe we do this on a whiteboard, then transfer this to a program like Visio, okay? All right. So more documentation and asset inventory. So an asset inventory is a comprehensive list of network devices and resources. So let me get my face up here. So this is more like, almost like the management side with our asset inventory. What we mean by that is, as a shop, or as an IT operations, as the networking team, we want to have, even if it's just an Excel sheet, there's other programs out there that do this for you. We want some sort of inventory where we say, hey, at these sites, we have these type of access switches, Catalyst 3800s, that are EOL or end of service at this time. What kind of warranties, what kind of licenses do we have to them? And we kind of want that huge sheet, whatever, even if it's just Excel, explaining what we have, what we own as a company, and then also lets us know as a network team what our responsibility is. So asset inventory, typically going to include hardware, software, licensing, warranty support, some sort of list and details of the different operating systems, firmware that we have to keep track of. Now, physical hardware, how many routers, switches, servers, firewalls, and workstations do we may have, and what are those device models, right? What are their serial numbers? Maybe location, that could be a location in the network or a physical location in our asset inventory. So you can kind of see here just a little tracking template here. This is like an Excel spreadsheet, but that does work, right? It may not be the best solution, but that is something that works. Okay, something that's very important for network engineers is IPAM, IP address management. If you're working in a NOC with multiple sites, maybe a global enterprise, or even if it's a regional enterprise with 200 locations, you could be a network engineer for something like Dutch Bros Coffee. And you may have to have IPAM for every single one of those spokes or outsides, okay? You need something to do that. You need something that can manage, plan, and track all the IP addresses in your huge enterprise. So on the screen here, I have something called Netbox. That's an amazing IPAM that allows a lot of API integration to help codify your network, okay? This could be your source of truth as far as IP addressing goes for like infrastructure as code, right? But besides, I'm not just trying to sell you Netbox, but IPAM is very important. These systems can provide reports on IP usage, detect potential issues such as exhausted subnets, right? The source of truth for the entire networking team. And then on the service provider side, whether you're working at an ISP, CSP, or MSP, or maybe you just have customers that expect some level of service, you got to be aware of what an SLA is. So a service level agreement is a formal contract between a service provider, whether that be internet, managed services, cloud services, and the customer that outlines the expected level of service. You typically hear a term used called the 5.9, so 99.99% uptime for whatever service you're providing. And then another important thing for network engineers, Wi-Fi, I think, most of the time I've consulted, it's been, how's the Wi-Fi going to be? What's our users going to be? So we'll plan the backbone architecture, the network. That's the fun part, right? And then what also is fun is setting up the Wi-Fi map, right? And to me, it's all part of network engineering, but I get into like a different mode when I come to like, where am I going to place these access points? Where's my best RF propagation? What's going to be in this room that could potentially have interference? What kind of channels? It's just fun. But something that we're going to have to do is called a wireless survey or heat map. This is conducted to map out the wireless coverage within an area, and the goal is to determine where wireless access points should be placed to provide the optimal coverage, okay? And it also helps us say, where's our blind zones? Where's our no service areas? So we call that a heat map, okay? Identifying dead zones or areas with poor signal strength. All right, now let's go ahead and do our quiz. So you can see here I'm on our learning management system. Let's go to our Network Plus course. Let's come to our lessons here. Let's go to domain 3.1.1 and let's go ahead and take our quiz. And I'll zoom in here. So question 1. Which of the following best describes a logical network diagram? Okay, logical diagram. I'm going to go with B here. A diagram that focuses on the flow of data and the IP addressing within the network. Awesome. If you want an explanation, we can see that here. Question 2. What does a wireless survey help identify in a network environment? Wireless survey. We're going to go with areas of weak or strong wireless signal coverage within a building. That was a pretty easy question because the other answers just made 0 sense. Question 3. Why is IPAM, IP address management, critical for a growing network? Not the physical location, not the arrangement. It's your IP addressing, right? As we grow as an enterprise, the earlier you get good IPAM done and a good system in place for managing where the subnets are, what prefixes are located where, assigned to who and what sites, the easier your scaling is going to be, especially when it comes to any sort of migrations. Okay, question 4. Which of the following best defines a service level agreement? Not a diagram, this is a contract. This is a contract outlining the expected level of service between a provider and a customer. Question 5. What is the primary purpose of a rack diagram? So that has to document the physical arrangement of devices in a network rack. Then question 6, what layer of a network diagram would focus on switches, MAC addresses, and VLAN configuration? Hey, if we know our OSI model, we didn't have to do this lesson to know this question, right? Layer 2, right? All right, that's 100%. So I want to thank you all for viewing. Please feel free to like, subscribe, share this with your friends, and if you want to get access to our learning management system, hit that link in the description below to see if you can enroll in our Network Plus course or reach out to me and the team, and I'll see you in the next video.